Okay. Have the tables made, or it should say, has the table made its way around? Has the table made its way around? Okay, one of the things I want to get out of the way right away is on your table, your individual periodic table. Okay? I want you to find element 28, which is nickel. Okay? And the way it's arranged, look for these little numbers in the upper left-hand corner. We're going to refer to that as how we identify these elements. You either would have to say find nickel, but an easier way of doing that is saying find element 28. Okay? Because if I said find tungsten on there, someone give me the abbreviation for tungsten. Nope. Someone found it. It is W. That's right. So that's why we refer to these as saying find element 28. Find element was tungsten 74, I think. Okay. That's why we do that, because some of these have Latin names, like wolfram is Latin for tungsten, and that's why it's named that way. So, in element 28, notice on one side on the top, it's got 28 on the upper left-hand corner, but only plus 2 in the upper right-hand corner, correct? That's a little plus sign, okay? Notice how that's different than like element number, let's say, 17, which is what? Yeah, chlorine, which is -1, okay? So I just want you to be able to see the difference between a positive sign and a negative sign, okay? Because these are the charges that are associated with each individual element. So nickel can also have a +3 charge. So make sure that you have +2 in there and +3 inside that nickel box. You just have to write that in yourself. So element 28 should also have +3 in there. Okay? Also element 25. Notice that's manganese, which can have +7, +4, and +2. Also put +3 in there. Element 25, put +3 in there. Manganese, element 25. Okay. Find element 82, which is lead. Notice it doesn't say L or Le or La, because there again, it's a Latin term used for lead, which is called plumbum, which is Latin for lead. So what we also want you to put in there is +4, 82. And notice it's only this row, not so much in the front, but probably U4. You could look up on that bigger periodic table. Notice those have more charges on there than what your table does. It's a little more, let's say, I wouldn't say advanced, but maybe more detailed. I just want to make sure we're going through and getting the appropriate charges in the appropriate spots, because again, some of them have more than what's on this table. Because I used to use a colored one, but it was so blurred it was hard to read the little numbers in there, and that's what made it difficult. The charge, you could say, well, that's kind of the same way. I can't really see them, but hopefully you can. That's why we're going through these right away. All right, so what has been your exposure to that of the periodic table? Not much at all, nothing at all, or not much. And that goes back to earth science, right? Because that, what's that, your magnetosphere? Yep, I believe that's true. Because that's what you find in the core, correct? Yeah. Okay. In Earth's core, it's nickel and iron. And that's why you have compasses that point towards the North Pole. That's one of iron's physical properties, because the magnetic pole of the Earth causes the compasses to point north. All right. So some of the things that we discuss in class, you're going to say, gosh, I never thought of anything that way. And hopefully we'll say that that's true. But for those of you who take general chemistry in 2 years, because we've asked this before, how many of you do believe that you are 4-year college bound? And if that hand goes up, general chemistry is required on your transcript to apply to college. Okay? Even if you're thinking, well, I'm going to go into nuclear medicine or x-ray technician down at Southeast or Mitchell Tech or something to that effect. Some of those chemistry classes are also required for that. So what we talk about in here is going to come full circle, and we'll find out who's really listening and who's not. Okay? It's one of those aspects we really don't want to make it so difficult that, oh my gosh, this class is awful. Well, we try to make it not only just interesting, but hopefully applicable to everyday life. Okay, even for some of you farmers. It used to be when we were growing up, inside all the cattle bunks, okay, you would have to have 2 blocks, not blocks of concrete. We're talking about blocks about like this, a cube, basically, a big cube. Salt is one, and you still put mineral blocks in there. Okay, well, why is there salt blocks in? Yeah, that's right. But why have salt blocks in there for cattle? Do we have to have salt as humans? Yeah, salt is a daily nutrient that you but a daily mineral. Whether it's a mammal or us as humans, we need to have that as part of our daily diet. And one of the physiological aspects that deals with that is we retain water as humans because of different hormones causes us to retain sodium, which is element number 11. Okay? Sodium, as we retain that, water will, one of its properties, follows the sodium. So if you keep retaining sodium ions, what are you going to retain more of? We just said. You're going to retain more water. Also, some of you athletes drinking not just Powerade, but also, well, could be. I associate that with maybe older people, but yeah, I suppose.
It's got like 3 bottles.
Also, what's body armor? Is that a type of? It's an energy drink. Is it worth it? It's not worth it. It's good though. Probably because it has more sugar to make it taste better. Okay. The reason I say that, okay. There you go. When you think of the very first soft drink, what do you suppose were some of the very early that you would recognize today? Coke is one, and Pepsi isn't. Pepsi and Dr. Pepper aren't quite around as long as what Coke has. I would say Coke, then Dr. Pepper, then probably Pepsi. But like the individual on the back had said, yes, there actually was traces of cocaine in Coca-Cola, and that's how it got its name. But what had happened, okay, is that people would be getting headaches from drinking this, and it was probably from the withdrawal of having that cocaine in there. And one of the things that they had to do, the taste was so bitter that they had to continually add sugar that you could actually drink that Coca-Cola. Because how many of you, if you had your choice, we'll just say, I think Dr. Pepper is probably more common than Coca-Cola. If you are at an establishment and you order either a Diet Dr. Pepper or a Dr. Pepper, are you saying, I would rather have it out of a can or a bottle as opposed to out of the fountain? How many of you do not like fountain pop or soda or whatever? I think you can, yeah. Okay. And that's probably true too. The reason I say that is what happens, okay? What happens, what happens is there's actually bags of syrup of all these different types. You wouldn't want to drink just the syrup because it's just like maple syrup, but it probably wouldn't taste very good because it'd be a lot sweeter than maple syrup. So you mix that with carbonated water, okay? And then it's just something you don't think about. You hit it underneath the tap, and it comes out of a bag and mixes with that carbonated water and gives you your assorted flavor of soft drink. Okay, so there's many different types of applications that are important on this periodic table, and I would say sodium and potassium are probably pretty high up on the list. Now, that's not to say that elements like iron and manganese and other elements like that are not important, but I would say those are two of the more ranking ones that are probably some of the most important to us as far as our daily diet is concerned. So, getting back to what we call this periodic table, is it's arranged, as you can tell, in increasing atomic number. That's why you see we're saying find element 28, find element 30, which, okay, you're probably going to have a lot of this memorized. We're not going to say memorize this periodic table. That to me would be just pointless, okay? To me, I'd rather have you be able to learn and understand how to use that. Now, there are going to be different types of elements that you will be assigned that you are going to have to memorize, because that's one of those aspects that under a time constraint, when you're working on, for instance, ACT test, there's nothing worse than looking on a periodic table trying to find, well, where's sodium, where's iron, where's zinc, where's tin, where are all these elements at? But if you can get them memorized, again, not the whole table, just specific elements. But is there anything else that stands out in your mind on how this periodic table is arranged? Increasing atomic, are you making a circle? No, it's not that I'm shocked if you would, but there's a very good reason on why you should be making a circle. Oh, okay. Because when you look at an atom, just any individual atom, it's actually arranged in a circle. Because you have protons and neutrons in the middle, and what do you suppose is circulating around the outside? The electrons, the third subatomic particle. So when you're making that circle, thinking, wow, you're way ahead of the game already. And we do have circles in here too, and I'll show you why that is. But the main thing that we want you to learn right away from the beginning, these are arranged from increasing atomic numbers from left to right, okay? And that there's 8 main columns that we want you to associate with. How's a column different than a row, do you think? Columns, are they this way or are they this way? Vertical, kind of like these are columns over here, okay? So we've got 2 main columns over here. We would skip these next 10 and then these 6 over here. The number 8 is going to be pretty important here when we get further down into this curriculum. Okay? And maybe as you're looking at this and listening to this, oh my gosh, this is so boring. And I wouldn't be offended if you had said that, because not everyone wants to go or find science interesting. It's just something that you have to go through. Maybe kind of like the daily grind of free throw shooting or serving or running or any one of those. It's just something that you have to do to prepare yourself for whether it's the next sporting event or practice in music, whether it's an instrument or singing. Or is anybody in the play in here? You know, that's something that you have to memorize. It's something that you have to do. It's part of that, again, that daily grind, for instance. Okay, so as we move forward then, so some of these properties then, as you're looking at a lot of scientific shorthand, what does that mean? A lot of abbreviations on here. They're 1 and 2 letter abbreviations. I'll come back to this in just a moment. I want to see what's what. Okay. Okay. Does everyone have this information that wants it? Okay. Now, if you think, in your opinion, if this part of this curriculum or this content could be difficult, okay, and you really don't know yet, what we're about to do next, I would suggest that you write it down, okay, and that's probably a good life lesson for those of you who do go off to college, that when you're in a lecture hall, whether it's a TA, teaching assistant, or the professor, if they're up front and they're writing something down up on the board, that's usually a pretty good indication that you probably want to write that content down. Okay, you have to let me know how that turns out. Okay, you go ahead and you take that. Maybe so. I would not recommend that, but let's say, for instance, some of you are teaching assistants for the elementary, right? So what's it like if you're trying to explain something and they just keep talking when you're talking, and they're not paying attention to you? Is that rude? Elementary students, I get that, but isn't there a point where you should be able to take initiative on your own that this is something that we should do? Maybe yes, maybe no. I think so. Maybe just kind of like a lot of your parents were just getting old. What do they know? Do your parents know anything? Sometimes? Fair enough. Asked and answered. Okay. So again, if you think that this could be a little rough, the more time you spend on this, the easier it's going to be for you. And if I ever told you something, not this, don't write that down. I think I've said this before. Okay. So I don't know enough about volleyball and kind of about music, but if I ever said the more you learn, or excuse me.
Aaron, to the main office, please. Aaron, to the main office. Thank you.
The more you know about a certain topic, the less you have to learn. Have I ever said that in here? Let's say, for instance, some of you looking at in music or band or chorus, or you're practicing with Coach Husby at the junior high level. Okay, The plays you run in junior high aren't the same as high school. They might be similar, okay? But let's say you're looking at that playbook or you're paying attention during practice and you don't run those plays yourself, you eventually will. But if you actually know them already before you play at the varsity level, the more you know at that time, the less you're going to have to learn. And it's just a coincidence that we still have this up here. For some of you going into different types of advanced sciences in college, the more that you know about organic chemistry, the better off you are going to be. Okay, let's say, for instance, in football practice, the very first 2 days you're just doing nothing but run. You probably are anyway, but just doing nothing but running. I just use that as an example. What does it mean to weed people out? You get rid of the ones that you really don't want. Okay? If Mr. Hoth was still here, he would agree with me, and maybe we said that in other classes. Some of these chemistry applications or classes, they're known as weeding out classes. They're going to find out who really wants to be in that program, who really wants to succeed. Okay? So again, the more you know, the less you have to learn that next step. Okay, so what I want to do is notice it said sometimes these Latin names are used. Okay? So we'll just do this. One of them is if you know the symbol for iron, don't say it out loud. But how many of you know which one of those is the symbol for iron? Okay? So this is why you use some of these Latin names. Okay? So this is actually indolium. Okay? What's this one then? That's iodine. This one. This is finally your iron. This is iridium. Okay? So again, sometimes these Latin names are used. Okay? So let's say, for instance, if you're recycling metal. Okay? You want to take some metal to a scrapyard. They do have, I think it's Zabo Recycling in Sioux Falls. They'll do that with metal. You take a magnet, and if that magnet is attracted to that metal, what's in that metal? Iron. It's a ferrous type. That's what we call ferrous metals and non-ferrous metals. So that's where it gets its name. Ferrous is Latin for iron. Okay? So there are some, I wouldn't say practical applications, but that's why we have the periodic table with some of these elements and named the way we do. Sometimes it's one letter, sometimes it's two, and sometimes it has nothing to do with the letters in the name. Just to, yeah, a lot of them are synthetic or man-made, but yes, that's true too. Okay, so remember we had said the number 8 is going to be very important for the organization of this periodic table. Okay? So what I want you to think about, notice as you look at the top here, notice it says on top of hydrogen, it says 1A. Then it says 2A. Then when it gets over here to scandium, titanium, vanadium, and chromium, it doesn't say A above that anymore, does it? It says B's. Okay? So the number 8 comes from these 2 columns and these 6 over here. Okay? So that's why when you get over there to boron, element number 5, it says 3A, 4A, 5A, 6A, and all the way up to number 8. The next thing we want you to do is it's not on this table. Okay? But there again, I'll refer to like you 4 people a lot because you're sitting beside Bob over here, this big periodic table. What do you notice? What does it say right there? that vertical term. Periods. So this is the first period, second period, third, come on, sodium, and so on. So my point is, if you can, it would be really small, but it probably makes more sense over here to helium. Right next to there, put a 1. Okay? Then next to neon, put a 2. Next to argon, put a 3. And all the way down to radon, which would be 6. I think 1, 2, 3, 4, 5, 6. Okay? Okay, did everyone put those period numbers in there? There's a very specific reason we want you to do that. Okay? So, for instance, I want you to pick a number between 5 and 10. Number 7. So again, this is how we refer to these elements. Okay? What's N? Okay? So, why would we put N on here? It's the 7th element. Okay? So when you say 7, I'm just going to put that there. Okay? Now, when you look inside that box, it says N, then it says nitrogen, then what does it say below the nitrogen? Okay? So we're going to put the 14 up here. Okay? This is a little bit of a preview of what we're going to be doing tomorrow. Okay? So what do we know about atoms? We know there's 3 subatomic particles, right? 1, 2, and protons. Okay? Those are your 3 subatomic particles that make up all matter on Earth, the universe, all of that. Okay? So, what I want you to think about, remember those vertical numbers that you put in? Those go all the way across, like this. Okay? And the vertical numbers, the columns, 1 through 8, go here, here, and then these other 6 over here. 3, 4, 5, 6, 7, and 8. Okay? I want you to tell me what period is nitrogen in. It's in the 2nd. That's right. Okay? Then what I want you to think about is what column is nitrogen in. Now careful, it'll tell you that up above. It'll say something and then the letter A. It's 5A. That 5 is important. That 2 is important. Okay? So just picture this is kind of like a dice game. You took some dice, you rolled it, and you came up with a 7. There are certain predictions that we can make from this periodic table. You said the 2nd period. That's correct. You said the 5th column. That is correct. Okay? So, what happens, this goes back to your semicircle. This goes back to when you're going like this, kind of like your semicircle. That's essentially true how we draw these. Really, like tomorrow it says Bohr models. Those are in circles like this, but it just gets to be so confusing drawing the whole atom like this that I'd rather use semicircles. So what that means, this is called an atomic number. This tells you the number of protons. So nitrogen has got 7 protons. Okay? So inside this nucleus, we've got nitrogen with 7 protons. Okay? And there's an order of filling that these do. Okay? Notice that on the far left hand 2 columns, it says 1A and 2A. And it's kind of like sliding through on a board game. Something funny over there? Because you keep laughing about everything I say. I didn't know I was that funny. Oh, okay. So, this will make more sense, and we'll come back to this. Okay? This is what we call 1s2, 2s2, and 2p3. Notice, What's true about all of these numbers when you add them together? There's 7 of them. Okay? 2, 2, and 3 gives you 7. The same number that's in the nucleus. Okay? You had said what period is nitrogen in? That's why there's 2 energy levels. You had said it's in the 5th column, right? That's where this number comes from, adding those 2 together. And finally, notice it says all charges must add up to what? Must add up to 0. Protons have what charge? Positive or negative? Positive charges. Electrons have what type of charge? Negative. So if you have 7 positive charges and 7 negative charges, those add up to what? 0. So we'll pick up with this tomorrow. Left outside. If we're not totally clear, we'll still be all right. But is there any, we're on the bus so far? Because if you nod your head yes, you are telling me that you understand this. Middle. Okay? Right outside. Okay? Left middle. And right middle. Did I ask you twice? Maybe not. Okay, we'll catch up to you next time.